In this third tutorial of this video series, we are going to see how to make a set of plots in order to visualize the data obtained from our set of feeds files. If you haven't watched the previous two videos, I strongly recommend you watch those first before watching this one. Okay, so we are going to start by importing the dictionaries that we created in the previous tutorial. So here they are. We have DataDic1 and DataDic2. So we basically gonna copy these. So we copy that and we paste it here. Okay. So here are the keywords. We have all of them here. So basically what we are going to do is we are going to we're just going to collect this data which are in our dictionary. We're just going to collect them as arrays and try to make plots for each of them and visualize. So we are going to start with DataDic1. So we're gonna say exposure time. So actually this information is in the form of a list. So let's just say exposure time list. And to get the exposure time list, we just go to our dictionary and we collect the data with the associated keyword. So this is inside DataDic1, so we can just paste it here. So we're gonna say DataDic1 and basically here we'll have to include the keyword and we'll do same for all of those keywords later on. So the keyword in this case is exp time. So we'll just copy that and paste here. So our exposure time list is given by, we can get it as this. So actually, yeah. Okay. So we are going to see that for file in for feeds file, no, for file actually, because okay, so for file in DataDic1. So basically DataDic1 file of exposure time for file in datasec1 should give us the exposure time. And we have to close this. So we can put that here, and yeah, it's closed now. It's okay now. All right. So the exposure time list is, we can get it just with this line of code: datasec1 file exposure time for file in datasec1. We can move to the next list. We can get because we need to get actually all of these lists, the lists associated with all of this data. We have the observation start, we have the observations end, we have the seeing, and so on. Here are the others. So let's see, observation start list, and basically to get the observation start list we are going to use a similar line of code and just change the keyword just as we got the previous one. In this case, the keyword is mgdops. So we just copy this, we paste here. Okay. And we are just going to replace this keyword with mgdops. So I copy that and I paste it here. Okay. So that's how we get the list. So here I just pasted all the lists of corresponding to the other keywords. I just pasted all of them here. You can see we have the radial velocity list, the air mass list, air mass start, air mass end, the seeing start, and the seeing end. And each of them correspond to a keyword inside DIC1. As you can see here. So now we're gonna have to connect to convert this to arrays. So we can just say exposure time array equals np.array. So we are going to actually convert this to arrays. So we need to use np.array from the numpy module to convert this, but we didn't have that, so we are going to import numpy, the numpy module. So we just say import numpy as np. Okay. So this actually will enable us to convert this to an array because it's found in the numpy module. So just say numpy.array, and I'll copy this and I will paste it here. So similarly, we do same for the next one. array in small letters, yeah, of the observation start list. So basically a list is just like data that's separated with commas, and the array they're like individual values which we can easily plot. So to plot a data, it's better to have them as arrays. Okay, so here I have just converted the other ones to save time. Yeah. So here we have all the lists above converted to arrays. And essentially, when you want to plot data in Python, you want to make sure that they are in array form, because you can't plot data as lists. You want to have them as arrays. It's easier to manipulate data as arrays and to plot them. It's more convenient to be plotted, to say it simply. So we're just going to see plot 1. We can start with the exposure time, or we can start with the observation start. We are going to plot each of these, each of them, one after the other. So our first plot, we are going to see import Matplotlib as .pyplot as plt. So to plot curves in Python, you will need to import the Matplotlib module. So we say plt.plot, we put an x value and a y value, basically. So we can just need to use it in this form, plt.plot, the x value we put it, and the y value we put it. So we are going to plot the observation start array with respect to the radial velocity array. So the first one will be a plot for the radial velocity. And since we have the radial velocity error, we may just want to plot error bars. So we're going to say plt.error bar, and here essentially it's similar to the one we have above, just that in this case we are going to include the error values in addition to the x and y values. So I'll just copy this, paste it here. Here I'll add the radial velocity array. So I'll copy this, I'll paste it here, okay. And lastly, I'll add the radial velocity error array. So I'll copy this one here and I'll paste it here. So we have that. So basically, this will just add error bars actually to the plot of observation start array and the radial velocity array. We can add a color. We just put a column. In this case, I want it to be red, so I just put an arrow and I will label it as curve 1. We can just call this curve 1. So I will label it as curve 1. Similarly, for the error bars. E color equals, let's just see, green. So FMT equals O is just like saying, okay, we want to have circles for the plots, and we would like the error bars to be green. So we are going to label the x-axis. The observation start array. Observation start, and this has units of days. Actually, it is measured in days, as it was written inside the master file. And the y label, we have the radial velocity, and we can add the unit, it's kilometers per second. So we can just put this. And lastly, we see PLT. We're just going to see lastly PLT.show to like represent this curve. So let's see PLT.show. Okay, and we put this parenthesis. Yeah. So basically, this is how you can establish a plot when you have an X array and a Y array, and whether you have error bars or not, you can always set them in this way. Similarly, let's carry out the second plot. You can just copy this and paste here. So in this case, we are going to have a plot of the observation start array against, let's look for another quantity here. In this case, let's see the air mass array. So we are going to plot the air mass against the observation start. So I'll just kind of copy that and I'll paste it here. Okay, so here we have observation start array, air mass start array. You can change the color. We want it to be blue, and we change the label to curve 2. So the error bars, in this case we don't have error bars, so I will remove that. Yeah, the observation start is still in this, but here this changes, so we need to change this. Now we have an air mass, so I'll just see air mass for the Y label. Here I need to add a plt.figure since I already have a first curve. Yeah, so adding a plt.figure enables the second curve to be plotted on a separate figure, if you like. So basically this will give us the second plot. Yeah, so that's it for the second plot. Let me just add start here to mention that it's the air mass start, because we are going to now do another plot for the air mass n. So let's say plot 3. I'll just copy this guy and paste it here. Same thing in we are going to make a plot for the air mass n array, as you can see here. Yeah, the air mass s, and this is it. So I'll just replace that with n. Nice. We can change the color. Let's just add another color, green in this case, and I change this to curve 3. Nice. So the observation start in days, and now the air mass, I'll just replace this and put an n and a plt.show as usual. So let's see plot 4. Can just copy this again and paste it here. So now we are going to have the observation start array, but now we're going to look for another quantity, the seeing. Yeah, so let's start with the seeing start. So we copy this and we paste here. Okay, so this is the seeing start against the observation start array. Again, we can put another color. Let's just say orange, and we label this curve 4. So we change air mass n to seeing start. So let's make the fit plot, plot 5. Just copy this and we paste it here. Okay. Now in this case, the seeing n, so we replace that here and I'll put n. Nice. Which corresponds to this guy here. So we can here we have that. Cannot change the color, let's just say yellow, and we change the label to curve 5. Here we have to replace start with n. Okay, cool. So the last plot, enable that plot 6. Basically, we can just copy this and paste it here. Nice. So we are going to replace the seeing n array with the last one, which is the signal to noise ratio array. So I'll just copy that and I paste it here. We can choose another color for this one and curve 6. So observation start in days, but now here we are just going to say SNR. So we're going to remove this and say SNR. So the signal to noise ratio. So there we are. We have this our 6 plots for this data, for the first part of the data, because remember we have 2 dictionaries. Here we just plotted data corresponding to the data in the first dictionary. So we are going to visualize this and see what it looks like. Here we go. Yeah. Here are our 6 plots. Here is the first one for the radial velocity, kilometers per second against the observation start index. You can see we have our plot, we have the error bars. I will zoom in. Yeah, you can clearly see we have the error bars. Let's zoom that here. I zoom here. Yeah, nice plot, beautiful. So the second plot, that of AMS start against the observation start. We have this kind of smooth parabola, almost a parabola. You can zoom in. Really very smooth. We have the third figure, which is that of the AMS N. Also kind of very smooth. This kind of minimum value, kind of paraboloid. If I zoom in again, I can zoom here, can zoom here. Yeah, very nice. Let's look at the fourth one. Just have this kind of dots. It's that of the seeing start. And if I zoom here, we have like points. Some are uniform, others not. But they're kind of dispersed everywhere in space. Okay, nice, looks nice. The fifth one, we have that of the seeing end against the observation start, as you can see here. Let me zoom in. You can see, kind of very nice. I zoom in, I zoom in, I zoom in, and I zoom in. Kind of very parallel, kind of fun. Okay, let's look at the sixth one, that of the signal to noise ratio. Let's zoom here. Yeah, kind of nice curve with peaks here and there. So let's close this one by one. Okay. So that was it for the first dictionary. So now we are going to try to plot, to make plots for data in the second dictionary. Essentially, it is in the second dictionary we have the wavelength, the flux, and the error. We're going to try to plot all of that. We have our wavelength, we have our flux, and we have our error. So I'll just we'll try first to obtain the arrays, just as the lists and the arrays for the wavelength, the flux, just as we got for these ones here. So in this case, we are just going to say wavelength list. Just as for the first case, we'll try to get the wavelength list from the first dictionary. So I'll replace here with 2. Here we just see wavelength, which is the keyword for the second dictionary, for file in datadic2. Okay. So undefined name. Okay, it's okay there. So we are going to say flux list, and then we are going to say flux error list. Cool. So basically it's kind of the same thing. We'll just change the keyword. So here I'll remove that and I'll put flux, and here I'm going to put error. Cool. So here we have the list for these 3 quantities. Now we need to convert this list to arrays. So I'll copy this. can just copy that, and we try to switch this to an array. Paste it here. I'll just say wavelength array equals to np.array, so just as we did above of wavelength list. Cool. So it converts the lists into arrays, and we can plot it later. So I'll copy this too, I'll paste here. I delete this, we say flux array equals np.array, and we paste the flux list. Similarly, we do same for the error on the flux. Copy this, I paste it here, I remove list and I put array equals np.array of the flux error list. And I will just add this, so it will be kind of bulky, very bulky, so we may just want to mask this flux error because it may make it very bulky. You can imagine we have we have like 200,000 points, so we ignore that for now. So here I've just pasted I just copy and pasted basically the plots from what we did above. So a plt.figure, so I'll replace the wavelength array here, and here we are going to insert the flux. So we are going to try to plot the wavelength against, I paste it, against the flux. I can just change this color. So actually I just realized I didn't add a plt.label for the other ones, but well, it doesn't matter much. What matters is that we can visualize the data. So I will label this the wavelength is in angstroms, and we have our flux, which is in some kind of electron units. Well, you can leave that, it's not very important. So here we have that. I'll run this part of the code and let's see if we get a plot. Let's see what it gives. Okay, it's loading. Okay, not responding. I guess it may be kind of very bulky. That's what I was expecting because we have like 52 arrays of 20,000 points each. I think I'll close this. It's kind of very bulky, really bulky. So I think what we'll do is, let's just try to plot. Let's just try to take one of these files, because here we have the 52 of them. It's kind of very bulky. 52 times 20,000 points, it's much. So I'll just take the first file of these fits files here, the files 0, and we are going to, it will be less bulky here, it will be less bulky, so we will be able to plot it. So let's just say file, let's see, file 1 equals to fits.open of file 0. So I'll just, so what I'm basically doing here is I'm taking the first of those set of fits files. So actually it's files with S, yeah. So I'll just take, so we are just going to take the wavelength and the flux of phi 0, the first phi, and we try to plot it. Since it's very bulky, this one should give us, generally they will have all of them the same shape. So it should be that much of a big deal. So I'll just say wavelength equals, so let's get the wavelength of this guy. I'll just say phi 1, just as we did for the header unit above. The only difference is that above we had header unit, here we have phi, so I'll say phi 1 dot data, and I paste the variable wavelength. You want to get the data of the wavelength inside phi 0, the first phi. Let's do same for the flux. The flux would be file 1 indexed by 1. It's in the second section, if you remember what I explained above, dot data, and here I put the flux. So we have the wavelength, we have the flux, and in this case we are only going to plot the wavelength and the flux and no more the arrays, just to see how they look like. This doesn't change, and okay, so let's run this part of the code, this part of the code. We're going to run it, and let's see. Okay, here we have plots this time around. Yeah, we have a curve this time around. So this is how it looks like. Let's zoom in. I'll zoom here. Dark. Okay, you can see there are peaks and there are areas where it's kind of packed, if you like. There are regions where they're so close. I'll zoom in again and again and again and again, and zoom in here, zoom in here. It's kind of nice to see. Yeah, so basically the 52 of those files, the 52, I mean, the flux versus wavelength for the 52 files look like this. So just imagine we have 52 of these on a curve with their errors. It's very bulky. That's the reason we didn't have it in the first plot. You have kind of a flat areas where it's flat, areas where it's bulky. Well, zoom in here, you can see, zoom here, and yeah. So basically that's it for the plots. This is how we can plot a set of data. It's kind of easy if you know how to go about it. And basically that's it. Yeah, hope you enjoyed this tutorial. I see you in the next tutorial. Let me close this. I see you in the fourth tutorial for the next part of the video series. Thanks.